This is HKOSCon, C-O-S-C-U-P. Yeah. However, open source communities in Taiwan are non-profit. In order to be tax exempt, several open source communities started to found the Open Cultural Foundation in 2014, and that's when community began to run a foundation and to run a non-profit legal entity. Okay, I have talked about the history of Open Cultural Foundation and explain why communities need a legal entity. Now, I would like to talk more about how OCF supports communities and what OCF does in recent years. The main goals of Open Cultural Foundation, OCF, is to promote open source, open data, and open government. We support local communities to advocate the use of open technology, such as open source software, open hardware, or open data. And we help government, enterprise, and non-government organizations better understand the benefit of open source and promote the importance of open data to the public. First, I want you to think about OCF as a house. We built a house for open cultural communities in Taiwan, and these communities can come to OCF to ask for administrative work, support, or even work with us. With this idea in mind, we have cooperated with more than 20 communities in Taiwan. Some of these communities are conference organizers, such as maybe GovZero Summit, or this is DebianConf, and this is JCCConf, Java Community Conference. And the others focus on community management, such as Open Lab Taipei, and this is Open Source Legal Network, or this is Open Hack Farm, in different fields. Next, I would like to talk about what OCF does. As a legal entity, OCF helps communities in three aspects: physical sponsor, administrative support, and international networking. First, as a physical sponsor, OCF shares our brand or our tax ID with communities. Communities can receive the sponsorship or donation from government or foundation and individuals without founding a legal entity. Also, OCF can help communities to give civic grants to others. For example, GovZero Joso organizer team have launched a civic tech prototype project. They encourage individuals and teams to join the civic tech community and to accelerate the incubation phase of civic tech projects. Second, OCF helps community to hire staff. PyCon Taiwan and the Joseon organizers team hire their staff from OCF to help them organize their events and community projects. Finally, OCF and the local community can connect with communities overseas and build an international network together. In this case, local communities can invite speakers to their events in Taiwan. On the other hand, OCF will help communities handle various things they will need to do during an event, or even join the international conference when they are busy in their stuff. In the beginning, OCF was interested in many fields and many social issues. And we realized that it is not enough to rely on one person or one organization to care about one thing. The best way is to build a community and gather a group of people who are interested in this issue. Therefore, OCF has started to build a new communities. We hope to find more people to the community, to join the community and to discuss with us. As you can see the process chart, there are 3 steps in community building. First, launch a new project, and second, build a community, and finally, the community run the project by themselves. We have experience in community building. I would like to illustrate the point through 2 cases. The first one is CSCS. It is Civil Society Cyber Shield. It is a project aims to help social activities reach the latest information security tools, fight against cyber threats, and promote social issues in safe online environment. OCF launched CSCS project with other organizations. We are trying to build a community to help citizen group. In the past, citizen group and the IT community, they did not know each other. What we are trying to do is to building a community between citizen groups and the IT community. For citizen group, we found some people who were interested in cyber security or privacy. From the IT groups, we are trying to find some people who were interested in consulting service for these citizen groups. And we try to build a community between citizen group and the IT community so that they can help more activists to promote local issues or social issues in a safe online environment. We have started a training project for those who would like to become information security trainers. So far, for the CSCS project, it has built a community, but it is still trying to run this project by themselves. In the future, we hope that they can build a stronger community and become a bridge between the citizen group and the IT communities. The second one is Creative Commons Taiwan Community. In 2003, Creative Taiwan project was launched in Academia Sinica. Creative Taiwan project includes Creative Commons porting project and the translation for the CC license suits, and also some local promotion activities. More than 10 years ago, 10 years later, CC Taiwan project decided to end this project. However, they started to cooperate with OCF and try to turn this project into community. Both of us want to build a community which can continuously promote Creative Commons in Taiwan. Therefore, in last year, we invited a group of people who are interested in Creative Commons to join Creative Commons community. And we also built a community named Creative Taiwan Chapter to communicate with our global Creative Commons chapter in the world. OCF built the international networking team 3 years ago. This team also works on bridging local communities and international communities. First, we support international communities to share their experience with local community in Taiwan. Second, we serve as a contact window while for the international organizations while they come to Taiwan, they visit in Taiwan. We will introduce open source communities in Taiwan and exchange our experience on open source projects. Third, we give travel grants for students to join open source events or conferences overseas to share their contribution to open source projects and even meet the intelligent contributor in the international conference. Fourth, we are partners of many international organizations. For example, we are a partner of UNI. It's OOMI. It's an open observatory of network interface. It is a free software and it is a global observation network for detecting censorship, surveillance, and traffic manipulation on the internet. We help UNI to run the software in our office. Also, we are a member of apc.org. As an APC member, we could expand our network with APC member network and meet more organizations. Fifth, we support communities in Taiwan to join international organizations. For example, we help GovZero to join Code for All, and we help Creative Commons Taiwan chapter to build Creative Taiwan communities to build a Creative Commons chapter to communicate with other Creative Commons in the world. Finally, we join international conference and bring back the latest information. For example, this month, my colleague and I are attending all kinds of international conferences and hackathons. Two of my colleagues went to North of Africa to attend RightsCon, and another colleague of mine went to the Okinawa and to attend a hackathon hosted by civic tech communities from Taiwan, Japan, and Korea. It's an Asia hackathon. Yeah. And it is a good way to meet overseas communities face to face and to discuss further cooperations. In recent years, apart from attending conferences related to open data, open government, or civic tech, we also join other kinds of international conferences to meet more communities and organizations related to human rights and internet freedom. We have learned a lot from them and realized that open source communities in Taiwan can collaborate with them, and therefore we bring the information back and the network back to Taiwan, and hope that local community can have a chance to work with these international communities and organizations. Now, I would like to introduce a new project. It is an open source newbie village. We are planning a training project, training courses this September for newbies to learn how to use open source tools. And we hope that everyone who is interested in open source can join this 2 weeks training course. This project is for two types of people. One is open source beginner who doesn't know how to use open source tools, and the other is open source developer project who is interested in devoting themselves in open source project and public affairs. They can cooperate. We would like to invite you to join this project in Taiwan and in this September. so that we can exchange our experience on open source tools and even work on the open source project together. If you are interested in open source newbie village, please come to me later. By the way, you can also join PyCon Taiwan at this time, at September. Okay, let's recap. What OCF do? We can divide the OCF work into 4 categories. Community support, organization collaborate, international communication, and consulting service. We work on many issues related to open source and open cultures, and we also collaborated with communities in various fields, like information technology, like legal or education and finance. After listening to the story of OCF, you might be thinking about founding a legal entity. Wait a minute and think again. Why? You might ask. Let me tell you some of unsolved problems of OCF. You might feel that founding a legal entity is not that easy. So what are some of greatest challenges for OCF? First, there are only 3 to 4 people in OCF to support more than 20 open source communities in Taiwan. Therefore, we hope to reduce the paperwork and the administrative work to them so that they can have more time to focus on other issues. Second one, traveling around the world to connect other international communities and organizations costs a lot of money. And it is always difficult to us to find a stable fund to help us and to help Taiwan local communities expand our network. Finally, the major problem is that we don't have a steady income to hire more staff to support local communities. We are still looking for solutions to our problem. If you have some experience about community management or legal entity, especially the non-profit legal entity management, please come to me and maybe we can discuss and we can exchange some ideas. And it's the end of my presentation, and thank you for the attention. And this is my cute cat. Just show him. Thank you. Is there further questions?
If there's any question, feel free to ask her now.
I probably have one. Okay. And we are close. If I understand correctly, OCF is an NGO organization.
Yes.
So I'm wondering what is the most stable and steady financial income so far?
To be honest, the stable income is from the conference, from those communities. As you can see, it's most stable income is from HKOSCon, PyCon, and the CCon. They host their event annually, but if maybe one day HKOSCon said we don't host this event this year, maybe it was a problem for OCF. Yes, so that we have individual donate for months. We want to gather more power from individuals, and we want to have a small fund that we do not rely on the HKOSCon, we do not rely on these communities, and we do not rely on the government project, and we can still in Taiwan to help other communities. Yeah.
That sounds a really big challenge.
Yes, that is a really big challenge. So we are a friend with them.
Okay. Thank you.
So if you want to donate us, please search ocf.tw/300. Yes, it's you donate 300 a month, and we can do more things for our communities. Yeah,
Is this $300 or Hong Kong dollars?
$300.
Okay.
Yeah, $300.
Thank you very much.
Yeah. Have any further questions? Okay, thank you guys.
内容做再练20遍。
好，
对，内容做。
真的吗？内容是有可以加的吗？
要剪。有一些句子像是YouTube，不是演讲。这个是大家看着荧幕，然后听你讲话。中间那些，但是还是有一些句子要可以，但是对，先练手，再说。
还有现在其实这个 track， 这个 track 现在已经在 YouTube 上在 live 的。
要不要帮你们放音乐？不然很干。我以为8个小时。
那就反正不好意思啊，
然后开 YouTube，好，所以是用4猫的币。
你要用你的也可以。
没有，如果你是 say 好，你就不要动。那我最后一个 track，所以不用。
你有 HTML
要自己画。HTML 想是 OK 的。
对，比如说就是你叫做哇，你的调调不是。
对，但是，对，但我觉得是熟了一点，或许自己也可以。就是像他问我问题，我这样的回答是有点。但是不讲稿，整个的内容架构，我讲的架构。
那个比较美化，就是那个3个政策，就是我们做的大概是有什么事情，然后做什么什么医学，然后像这个图是对的，而且那个图是他会去给 technology 提供什么是我觉得非常适合，因为他们对他们来讲，那种该架构的能够负责，但是他需要这样才能给一般人。
这边是正常的吗？
我从这里看。
这边看正常哎、是这里出去的问题吧？我这里看你的画面是正常的，这一端出去的问题。
好，那等下他来再叫他进来。不知道你架构什么。
不敢乱动。
对啊。
那应该是16:9哦。
他那边16:9啊，但是出去的时候的那个全部是4:3，这样。
4:3。
所以它就会是一个16:9塞在4:3。
是不是在这边调4:3就会比较好？
我不知道，
我看起来
他的
没有
软体是怎么样。不过你现在这样，不过现在这样不准啊。现在这样子，不然发什么事情都不准。
继续扫菜。
你如果用4:3，搞不好会这样去做。你说旁边有颜色？不，我的意思是说，它的 OBS 出来的时候是4:3。它可是我说它的 OBS 放出来串在这里的都是4:3。然后旁边那边是因为投影机资源到程度。就是一个怪怪的状态。
我现在觉得不要跟你比人好用，快多了。本来就准备贴上去，然后别人这里
你画面是正常的啊。
但是你只要注册，它就会自己给它这个习惯。
没有从大部分吸收一点。
现在是怎样？你跟偷偷的？
对啊，因为算错这样。大概看一下。
OK，我要按照这个就行。这个有点松。哦。还好吧，现在。
没什么，还是一样。
现在我
西多士。
就西诺这边超了，知道吗？
其实是 OK。
可以，这是一个做法。比如说广东收一。
另外一个在这边吧。
不是，因为那个就是。丢到。 嗰啲個工頭係攞落嚟。
呢邊工。
啊得，我哋。
唔該唔該。
好。俾人踩到爛晒。
斷咗個心。OK。呢條係科學園嘅。
科學園。
係啦，有㗎。如果唔係自己看翻。
黐線。
都幾廿蚊喎。
15條心啊，大佬。
好辛苦咯，我看咗。唔得，好煩，我會買個先就。睇埋好多會難嘅。
買咗一個壓到爛死，本身有個 patch gun 好唔夠嘅。
Good afternoon, everyone. Hello. I know some of you might have already heard this, but I have to repeat it again for the newcomers. That welcome to the HKOSCon special track, and it's our honor to come to Hong Kong, and we're really glad to see you here with us. HKOSCon is an annual conference held by Taiwanese Open Source Conference, and we aim to provide a platform to connect coders, users, and promoters. This year, on August 17 and 18 in Taipei, Taiwan, we will have an annual conference, HKOSCon, more than 19 different topics from 14 tracks. And you can join the BOF. You also can share your ideas in lightning talks. And the registration starts in July 10th, and it's free to get the tickets. And we have a booth outside on the wall, and so you can go to there and see all the information you might have need, and find out how to get the ticket and find more HKOSCon information. And now we are going to hear the Ying Xin share the model promoting open source pathways. Let's give her a hand.
Hi everyone. I think maybe after this talk it's lunchtime, so I will take my time. And today I will show my experience to promoting the open source pathway. Why I say mogul? Because I'm not an engineer, I'm not coding, I'm a marketing and salesperson. But I in the open source events to about 10 years. So I want to sharing this experience using HKOSCon sponsor team and media teams experience for example. And I'm Shasha. This is my nickname. It's my ID in this community. And I am a volunteer in open source group in Taiwan. And I have 10 years of volunteering experience, mostly responsible sponsor and media PR test, where I community and promote the sprint of open source to business owners, the media and the public. 就是大家好，我是莎莎。那这其实是一个历程本，在社群很少用本，那只是我就是在台湾的 open source 圈里面当志工，大概是10年的时间。那这10年里面，大部分都是在就是找赞助这件事情，或者是媒体主这样的事情，负责媒体啊或 PR 这样的一个工作内容。那我其实很喜欢，就是做这件事，可以告诉很多的企业主，告诉媒体，告诉一般人没有接触到过 open source 的人，告诉他们是什么是开源精神这样的事情。 And the HKOSCon will on October every year. And I think you maybe listen the introduction, so I will pass it. 我刚刚听了思毛的开场，主持人开场，我想大家应该已经都很知道 HKOSCon 今年是在8月在哪里，然后做什么事情，所以我就很快的把这也跳过。那我就会讲几个我觉得它只是比较有趣的事情。And the HKOSCon have 30 rooms, so it has a lot of tech tracks. So you could find any topic you are interested in. So I think it's very interesting. And I think we have a lot of people join this event, more than 2,000 people. And so we have more than 1,000 volunteers. It's very amazing. 在就是 HKOSCon 大概有10几轨的，就是演讲，你应该都可以在里面找到你有兴趣的东西。然后有大概超过2000个人一起来参加这个活动，然后500个志工。我觉得这在这个世界上，它是一件很惊奇的事情，很特别的事情，很少有这样的一个东西可以出来。And I said, I have 10 years volunteering experience, mostly in sponsor teams and media teams. And from 1811 to 1816, I joined the sponsor team. And we had one writing principle. We think, what makes a good team? We think teams should have engineers and have markers. Why? Because we think it is helpful in order to contribute fresh ideas but maintain the open source culture and events. 大概我有5年的时间都在找赞助的这种主编里面当职工。然后那时候我们有一个不成文的规定，我们认为说组员里面应该有1半是工程师，另外1半绝对不能是工程师。为什么呢？我们会觉得这样子才是一个很不错的组别，是因为我们认为这样可以维持大家可以想出来的点子，好点子，可以不违背或者是很符合社群的这个文化，可是可以做一些有趣的新鲜事。所以我们认为人这样的组成是很重要的。And I think one thing I think is very important to me. And one year, we sharing our sponsor experience and raise money in the HKOSCon bazaar. Because last year we have a lot of sponsor account. So many people want to know how we can do it. So we sharing our experience and sell it. 有一年，我觉得有一件事是对我也很重要的，因为我觉得这样子对社群有回馈贡献的一件事情。因为那一年我们拿到了很多赞助的金额，非常的多，算是出乎大家意料的，在台湾很少见到这样的金额。所以我们在 HKOSCon 的那一年义卖上，就是义卖我们的经验值这件事情，我们办了一个小活动、小分享会。那你要参加这个小分享会呢，就可以听到我们怎么去找赞助，怎么做这件事，然后为什么拿到这么多钱的策略怎么做。我们希望借由这样的事情的分享，可以让更多的人知道，open source 专业其实很有趣，然后你可以学习到很多东西。Any other? Maybe I think 2017 to this year, I joined the media teams. And the thing we think some of our volunteers were engineers, and the other will make up of PR staff, and the other professionals. We think it's very important because they were a good team. 同样的，就是这3年我是在媒体组这个组别，那我们这个组别也有就是 PR 的角色。我们 们认为组员里一定要有工程师的存在。那其他的第二个重要的是一定要有专业的公关，就是他从事的工作，他本来就是可能是企业公关或公关公司的人员。然后其他的就是任何你不是公关的专业的人都没有关系，都可以加入这个专业。跟前面的道理是一样的，我们就是有工程师才能够符合社群的文化，但是可以做一些有趣的事情，但是感觉到很专业。And our staff need to be principled in order to deliver the event principles. 就是我们在想说，我们所有的组员想出来的事情、做的事情，都一定要符合社群的原则，或者是这个活动原本的目标。So, 2011, we do something new. We event the people a lot of power and vision, and they show the open source spring means to learn. 就我们邀请了那时候好几个在每个地方很有就是影响力的名人来跟大家分享，对他们而言开源精神是什么？我们想要借由这样的活动，可以让更多人知道说，开源精神这件事不会只有存在社群，不会存在只有工程师的世界里。And I want to tell you why I create the open source. Because open source helped me so much. I want to, for example, choose the first. I think the freedom of choice, because understanding that there are other choices besides Windows and Mac OS as in life, and we are not listening to only the popular choice. The world is your oyster. And second, the open mind is power. Knowledge is power. Then sharing your knowledge will make the world be a better place. If you build it, they come. 我在 open source 的世界里学到很多很多东西，其中2点我想要跟大家分享的是。第一个，我认为它教会我什么是选择的自由。就我觉得这是很有趣的一件事，可以类推到我们的人生。你在使用我们现在的人都使用电脑在工作，在做任何事情。那除了 Windows 跟 Mac OS， 你有没有其他的选择？有，因为 Open Source 教我们这件事情，所以你会有其他的选择。这个世界不是只有一点点，这个世界很大。第二个是。我认为开放就是一种力量，为什么？因为分享你的经验是一种力量，分享你的知识是一种力量。我们一起来做这件事，然后世界真的可能会变得更好。So I want to tell you, open source helped me. So why I think we should promote the open source. Finally, I want to welcome you join the HKOSCon this year. If you can help us to make this year to be better one, and this is our sponsor email. And I think I'll talk quickly. So, if you have any question, you can tell me, and I will show you our experience. Thank you. Everyone is hungry, so we want to lunch time.
I'm sorry, I still have questions. I know you are going to have lunch, but apologize.
It's okay.
Okay. I'm so curious about because you buy models.
Yeah.
I won't say it's models. It's the community. The community needs professional people, besides engineers. But what I saw is it's very hard to find out more people besides engineers. How do you encourage or find out people except engineers to join your community like HKOSCon? It surprised me that a lot more than or around 50% people are not engineers.
Yeah. Yeah.
So how do you find out people not engineers?
It's a good question because I never seen the question because it's very natural. Every year we want to more new volunteer, so we tell everybody you can join us be a volunteer. So you will someone tell you you want to join your team, and we will tell about this event meeting, and the people will join us. So it's very natural. I never seen this. Maybe Bob. Oh, no one. Okay.
Maybe I can add something that I am not engineer too, but so I can find things that I can do and I can contribute, and I feel it's fun. So I asked my friend, "Are you going to join me this time?" And I can tell them what they can do. So they won't feel too nervous or too worried that they don't know how to code, and they will worry. So just tell them what part you can participate. I think it helps.
And also, I can share my experiences now. I'm also not a programmer. I'm not studying in IT, and it's my experiences that I want to do the things programmer doesn't want to do. It's like they do not like to do maybe the administrative work, or they do not like to do the finance, or they do not do not like to do the maybe it's not familiar with this. So maybe I can do the marketing for this. So it is for me. I can do my best on one field, and maybe programmers can do the best on the apps. Community build apps, and they build a website. Maybe they schedule a conference program, and they want to do, so they do this. And what I want to do is do the things they don't like, or they are not familiar with this, but it's okay for me. Yeah.
I think in our team, my experience is the volunteer is like your colleague on the work. So you have to find the interesting topics for them, and you will help them to find the interesting task to them. So every year I help my team member do this thing, and every year we will show our experience on the social media. So maybe the other people knows if you are not an engineer, it's okay because you will find what you want to do in this event. So you want to do this, you want to try it, you want to try. I think maybe.
Yeah. Well, it's a pretty good deal. I asked one question and get 3 answers. Thank you very much.
Thank you. Sorry, I carried through so fast. If you have any ideas want to share with us, maybe 1 minute and save your time. Thank you.
Thanks to Shasha again. And we are going to have a lunch break until 2.
So what is AR scale here? In recent years, accelerometer sensors has greatly improved throughout the years. So we have AR kit in iPhone 6s or later, and we have AR core in certain Android devices. So with in the past, when we saw like these 2 images, we really couldn't tell how big the leap is, right? But now with AR scale, we have some confidence that in this leap, it's just like 10, 12 centimeters, but this leap is already 3 times larger. So with this data, we continue to research whether those factors help improve our research, help the identification accuracy. And so let's welcome our AI engineer to talk about the technical details.
Hello, everybody. My name is Rulu. And so we want to make our app to be able to tell what kind of plant a photo is. So we want to build a identification system, right? And we choose to do it in the AI way. But to do the AI way, it just means we need a lot of data so that we can train the AI model. But we only have 3 people. We cannot collect really much data as the big company is. So what can we do? We use a common technique called data augmentation. Because we only have like 25,000 photos. We want to generate more data. So using data augmentation, we can generate more, something like big data. We can randomly crop the photo, just like you cut certain percentage of the edges, cut them off. Or we can flip horizontally or vertically the photos. And we can tune the brightness and the saturation of the photos. Yeah, it is a useful technique to generate data, as long as you think changing these properties doesn't hurt the photos. If you think half the rows should still look like a rose, you can do the random crop. If you think you flip the rose, it should still look like a rose, you can do the flip. Yeah, if you think changing the brightness doesn't change whether it looks like rose, you can do that. And so to us, the answers to the questions are all yes, so we can do the data augmentation. So we generate much fake data, but it's still hard to use this data to train the big models. So we use another common technique called transfer learning. This is what the typical model looks like. They just read the images in the input in the first layer, and there are many layers in the middle. And finally, in the final layer, it tells the probability of each class. It's like, for example, if the probability of the photo being a car is 70%, and the probability of the image being a truck is 20%, and 10% for van, 5% for bicycle or something, then the model can tell the photo is most likely a car, something like that. And after
点一下，可能 focus。
TensorFlow Slim. It's open source. It's released by the TensorFlow team. It's a framework built upon the TensorFlow. The TensorFlow Slim is open source, and the key point is that they have released several pre-trained models. So it's very powerful for us, so that we don't have to retrain it. We don't have to train it on scratch. They have already pre-trained the model using 1,000 categories and 1.2 million images. So it's good for us. And we chose the model. We used the famous model called MobileNet. It's optimized for mobiles. We tried another models before called ResNet, but if we use the ResNet, the final model will be like 90 megabytes. But for MobileNet, we only have 20 megabytes. So because we want to build an offline mobile app, right? So we need a smaller model. So we have to use MobileNet. And it's because the model is smaller, it's also easier to train. And we only have to fine-tune. We call it fine-tune. Yeah, they are pre-trained, and we fine-tune the last layer. And this is our result. After like 6 hours, if you use a powerful GPU, we can train it to an accuracy of 97% for a training set, and for a validation set, we can achieve something like 85%. It's okay for us. And to understand how good our result is, it's useful to plot a photo like this. It's called a confusion matrix. The x-axis is the real label, for example, rose, sunflowers, or something like that. And this is the predicted result from the model. So we can compare whether the answer for the model is correct. So if it is really a rose and the model says it is a rose, then we will put a data point here. But if it is a sunflower but it says it's a rose, then it will be somewhere else. So if all the data point is on the diagonal line, it means your model is perfect. The prediction is 100%. So you can see that most of the data points is on the diagonal line, and then there are many points outside, but it's still okay for us because for the points outside, it's light. It's not many data points outside, so it's good for us. And also, we did a saliency map analysis. It means that we want to understand what the model really cares about our photos. We calculate the gradient of loss. It means if we randomly change any pixel of the photos, how much it will affect the result. If we modify this pixel and the change is high, it means this pixel is important. And we just draw those, and if it is important, it means the model is sensitive to these certain pixels. So these blue points are those sensitive areas. It means the model is where the model really cares about. So we can see that the blue points for this picture and this picture is is mostly on the petals, the petal of the flower. So it means the model really cares about the petals. And for us, it is correct, because in order to identify what plant it is, it's important to see the petals, right? So the model did the right thing as we expect. So it's good. And this is our app. Okay, this is our app. We export the model to the iOS format and Android format. On iOS, we use the core ML model. On Android, we use TensorFlow Lite. And here's a video. Let's see, can we? This is a result of.
So I have a short introduction of our result last year. For like easy one is blackjack flowers. Okay, commonly seen in Taiwan. Jianhua, so we are in Chinese here. So for some easy flowers, it's not difficult to identify, but if we have on leaves, sounds like it's okay to identify those flowers, or even something like this we can remove around the plant, it's still recognizable. Or even in such a dark light, we can still understand what the flower is. But we're not perfect yet, so like we have some defaults. So it's okay for this flower, but this is clearly wrong because it just has different colors, and when our data set doesn't cover it, it couldn't recognize it correctly. And it's okay to recognize this. And this is our nature in Taiwan. And so you see like this. We have a sign here for Taiwan Aster. It's a plant only in Taiwan, and we didn't do some OCR step to say, okay, it's Taiwan Aster. We don't do that. We don't cheat. But when we get closer, you can see it's still there's some possibility to identify it. So we need to improve it with more data or more technique to improve assistance. It still works to be done. So that's our talk here. So we have questions. We have 5 minutes left.
You said you will consider one dimension is the AR scale. Then how you fit this data to?
This is basic, the fast prototype of our product. After that, we can integrate that. We haven't used the dimension yet. After that, we can integrate into our body. Yeah. It is in the beginning. We expected we can use that we can use many features, right? The photo, the other dimensions. But so far we only use the photo, and the accuracy is good enough for us. So it's the what it is now.
Any more questions?
Well, in a network like this, sometimes we will have problems of overfitting.
Yeah.
So is there any regularizations have been done on penalizing the overfitting for the built-in environment?
We haven't had any regularization yet. But for the result, so far it looks good for me.
And my second question is, I can see the training model has been done to classify well-known species for the flowers. So what about like unknown species that is what should the network be trained to deal with the unknown species that the network hasn't seen?
We have a category called unknown, others, like that. So if you you take a picture of me to the app, it will say it's others. Because previously they were, if they see male people, they will answer a certain flower. It's funny, and for girls it will answer another flower. It's strange, so we add a category called other.
That's nice. Thank you.
Yeah, thank you.
Any more questions?
So when it comes to building the models, can you share more about what is the biggest challenge you have in building up the model?
Because because it is the first time for us. It's so everything is so new for us, and the biggest thing is still how to generate enough data to train the model and make the accuracy enough. But it's quite surprising because it's good enough for us in the beginning. It's acceptable for us.
Can I extend the questions? Do you do any hyperparameters, tunings, that kind of modification of the model?
No, not so far. You mean the crossword or something?
Tuning parameters, make it more.
Not yet.
Basically, I have a question. When we using the app, do we need a server to see the background or networks, or we just use the model in the client, in the iOS app?
You mean the training part?
I mean the model. After you have trained the model, the model is built in the iOS app.
Yeah.
Yeah.
We want to build an offline app.
So basically, what's the size of the model?
It's like
less than 20 megabytes. It's based on the technology of mobile net.
So it's like 20 megabytes. So but it's download afterward.
And another question is that when you have a picture, it basically has a foreground and a background.
Yeah.
So if you put the same flower in another environment, will it affect?
You mean the two kind of flowers in the same picture?
Not two kinds. You have different backgrounds. It will still show the answer. The correct answer is if the background is not too complicated. Not too complicated.
Actually, we don't have to have a circular label with where the flower is. We just took all the image data into the training.
The model will figure it out.
Yeah. So the result is quite amazing.
Talking about the transfer learning.
Can you be louder? Sorry.
Sorry. Talking about the transfer learning you have mentioned about, you guys have created some samples based on existing images to adjust the brightness or the contrast of them, etc. Did you have any specific strategy applied on creating this kind of duplicated images into validation set and the test set?
So you have said you have made some images based on existing images in the transfer learning, and so when you apply these images into your testing data set, did you just mix these images into the large pool of the testing set, or do you have any special strategy to apply those images into a specific validation set?
They are generated in different data sets. For this image, all the images it is augmented is in the training set, so they won't be mixed.
That means you didn't separate these augmented images into another training set.
Yeah.
Okay.
But
thank you.
they are different.
Any more questions? Because we are running out of time.
Yes, it's about 10.
Okay, thank you everybody for your attention.
If you have more questions, you can go to catch them. And we'll be back in 10 minutes. Welcome to the HKOSCon special chat. I know some of you have already heard this, but let me repeat again for the newcomers. That it's our honor to come to Hong Kong from Taiwan, and we are very glad to see so many of you here. And HKOSCon is an annual conference held by Taiwanese open source community since 2006. HKOSCon aims to provide the platform to connect open source coders, users, and promoters. This year, on August 17 to 18 in Taipei, Taiwan, we will have more than 19 different topics from 14 tracks. And you can join the BOF. You can also have the chance to share your ideas in lightning talks. And the registration starts in July 10th. So please come to our booth outside. You will find all the information you need, or you can just follow our Facebook or Twitter and just search the HKOSCon and you will get the information. So let's welcome the freedom to share the status quo of TensorFlow Lite on edge devices. Let's give him a hand.
Let's get started. My name is Guan Xin, and you can call me Freedom. I established this for 10 seconds. You can find the URL of this slide. I already put this slide deck in my Google Drive. You'd better get the slide now because I put a lot of link inside. So. And the screen is small and the solution doesn't look good. So, yeah. Okay, there's a disclaimer. Please feel free to interrupt me anytime. I have a lot of slides, but I think that I can skip many of them. So, my self-introduction. So who I am? I am a programmer. I learned to use, this is an open source conference. I learned to use open source before the term open source is generally used. So I learned to use open source and Linux on the VAX 11 780, which is a mini computer. It's running 4.3 BSD. I used to be a programming language junkie during college days. So recently, for the past several years, I work on various system software such as CPU scheduling. I work on CPU scheduling because I work for a SoC company which build SoC for cell phone, and cell phone has a big little stuff. You are aware of that, and many other components need power management. So for the past several years, I work on that. For the past about 2 years, I work on improving the performance of neural network on edge devices, especially on cell phone and tablet. I am a TensorFlow, or specifically TensorFlow Lite contributor. I studied command line level. If you use TensorFlow Lite and use command line stuff, you probably used my simple program already. Okay, so what I'm gonna talk about, I'm gonna share what I know about the neural network on Android device first. I think in previous session you already get the impression that TF-Lite is one of the most popular choice on Android devices. You know, mobile name is okay. But TensorFlow Lite is kind of interesting. It started from a simple interpreter, then evolved into a kind of multifunction stuff. So there are other open source stuff more beyond TensorFlow Lite. So if time permitted, I'll talk about it, and we can conclude this. So why TF-Lite? Yeah, at first why I choose TensorFlow Lite, because it's TensorFlow. It's about 2 years ago. TensorFlow is the most popular machine learning framework, and the TensorFlow Lite is just a lightweight framework for TensorFlow Lite, and it could be accelerated by GPU, DSP, ASICs, and other stuff. At that time, I found no other choices. So, and nowadays, probably you can use PyTorch or PyTorch Plus compared to, but it's not as comprehensive as the TensorFlow or TensorFlow Lite. Because what do I mean by comprehensive? Because TensorFlow has support a lot of the devices, languages, and its library covered the load and processing data, as previous session said. Previously, those stuff are not standardized, but for TensorFlow 2.0, it's kind of more standardized. There are stuff to build models, and for deploy to mobile devices, including IoT, you can use TensorFlow Lite. PyTorch is not covering this as complete as TensorFlow yet. So why neural network on edge devices, especially cell phone? In previous session, you see that one of the reasons is that your cell phone is the one you carry with you, and it has camera, so you may want to use it to say classify something, identify something. But typical argument for using neural network on devices is like offline usage, latency, bandwidth, privacy, etc. Okay, offline usage. So I heard, at least I heard, we heard words such as OS up or OS connected from the 3G times, but you know that OS communication is not always reliable. So we kind of like offline usage. So when you don't have connection to the cloud, how do you deal with that? Latency. Latency is a hard problem. I used to be a computer networking guy when during my PhD program days. This is one of the famous networking guy, David Clark. He is one of the father of TCP/IP. One of his most favorite quotations is that he cited all the network saying that latency problem is very, very hard to deal with because the light speed is fixed. Bandwidth, although he said that the saying said that bandwidth problem can be cured by money, but it's not easy when, say, you have a lot of bandwidth requirement on current, say, flagship cell phone. For example, so iPhone XS Max, it has 2 cameras. Even you count just one, it is not enough. Let's start with 2 cameras. Do some back of calculation. So this 12 plus 12 megapixel, and let's assume that you have 3 bytes RGB, something like that, or the YUV, and 24 bits, something like that, and you get for one frame, you have this much. You need this much bits. We don't talk about say 60 frames per second. We just count 30 frames per second. It's definitely this number, or say half of this number, is not what you want to change. What you can do nowadays for a cell phone. Privacy. This is the New York Times International Edition. I saw on my parent here. So yeah, it's a demonstration. You have to cover yourself. You need privacy, and your device can be a privacy tool. Yeah, it can be a pocket of a tool, but yeah, for this kind of stuff, we can go on and on. So let's get back to the neural network stuff. So neural network based machine learning is already on the devices. For Google I/O 2 years ago, Google shifted its focus. Previously, they said mobile first, but then they said AI first. We saw TensorFlow LiDAR entry, and then API announced, and a lot of stuff from Google Flagship, and for Google's flagship cell phone, Pixel 2, Pixel 3, it has a Pixel Video Code. And according to some documentation and this computer architecture book, it should support TensorFlow, but I cannot find any way to use it. Well, and Apple has CoreML, you know that. And Apple's neural engine, it's an accelerator. Neural engine is quite powerful. And yeah. yeah, you cannot read this. This is from Android and plus TF-Lite benchmark side. I think originally developed by some PhD student in the ETH. It collected benchmark data and performance stuff, and you can see that there are already many API enabled form. This is a field that evolved pretty fast. So in November last year, this is what I got from NetHack. NetHack, if you don't know, it's one of the good technology site. The site develop its own program to or methodology to probe, say, Apple CPU's cache size, execution unit, and say instruction latency, etc. It's quite picky, quite picky. But for neural network, at that time, it's not good enough. But no, things change. So TF-Lite, actually, every phone that is every Android 9 phone has TF-Lite inside. It's in system library. There is lib TF-Lite. So your system lib and system for the lib already. What it is used, I only find one usage. It's in the text classifier. So you select the text, and the text classifier will decide if it's a URL or something like that. And in TensorFlow developers submitted, they introduced many TensorFlow use case. Since this kind of stuff is not open source, so we just skim over that. For high-level stuff, Google also has a kit, which is part of the Firebase. It's not open source, but they use a lot of TF-Lite already. Originally, only a custom model part they use TF-Lite, but I think now most of those region application, region API use a TF-Lite model already. If you want to see more examples, those are not open source, so I put them into appendix. Before talking about TF-Lite, real TF-Lite stuff, let's review something that make neural network on edge device really valuable. I think it's all started for really useful mobile device. I think it's all started from SqueezeNet, then MobileNet, V1 and V2. Because of if you want to introduce the depth-wise separable convolution, and mobile V2, the linear automatic, the inverted receiver stuff, and then Google guys did more. They have their network architecture search, or sometimes called it AutoML, to find to use neural network to search network architecture. Recently, they have MobileNet V3 and something called efficient net. This making network to be as small as possible, but still keep higher accuracy. And another technology or technique is quantization. Quantization means that to turn your floating point stuff into a fixed point stuff here. Another, if you read academic papers, you can see a lot of pruning or say compression stuff discussed. That also should, theoretically, should help reduce the size of your model. But usually those pruning or say compression stuff need hardware, need special hardware to make them really useful. So as far as I know, they are not widely used. Yeah, that's it for neural network stuff. This is my comment. Let's skip this. Okay. So I started learning TensorFlow Lite back in 2014. I heard that Google I/O 2017, and there's a HKOSCon. I also have a HKOSCon talk. Before TensorFlow Lite really announced, at least me, I don't really know what TensorFlow Lite will look like. About the same time, we know neural network API, Android's API is gonna release. I work for an SOC company, so we kind of know. Google share information with SOC company on how Android API is gonna work. So, but we don't really know. We didn't really know how TensorFlow Lite. But TensorFlow Lite is really, makes things better or makes things visible is that quantization. Quantization is not a new technique. It's old. But TensorFlow Lite is one of the few devices or few frameworks that really make quantization work. And for connection or use the underlying accelerators, that's what TensorFlow Lite provides. So TensorFlow Lite in the Google I/O 2 years ago, it says that the TensorFlow Lite and an API and they can be DSP CPU GPU. But it's turned out it's not like this. The NN-API's CPU fallback it does not use NN help. NN-API is NN-API is part of NDK, so it's a C++ API. Android NN on Pixel 2, so Android NN. Yeah, NN API is there, but connecting with the underlying DSP or GPU is not there for Pixel 2. But NN API actually work. So as I mentioned in the previous slide, that you can buy a lot of new devices with an API and connected with accelerator already. Google's Pixel 3a also has an API to connect to the DSP already. Original TF-Lite has two API. One is Java, one is C++. There are other bindings later, so there are Python, we see API. I also wrote some. Okay, the documentation of TF-Lite improved a lot. that's nowadays. So when you use TensorFlow Lite is like pick a model, then convert it. It's not you cannot use a TensorFlow model directly. You have to connect it to TensorFlow Lite model and then deploy it. Then you probably want to optimize it. So it's the TensorFlow comes with a TF-Lite converter. We can convert say the chaos or TF estimator or the frozen PB stuff into TensorFlow Lite format. Basic usage, how to use TensorFlow Lite. It's like you load the model and call a resolver to resolve where the OP is, and the code interpret. And the code interpret just allocate something and the code interpret invoke. Then everything is done, and then you can just check the output. Okay. Interpret. Or before you call that, you have to allocate do some memory management stuff. And previously, I have talked in HKOSCon about the data structure of the interpreter, etc. If you would like to know more, and well, the interpreter is quite interesting. So because in the beginning, so TF-Lite, the computer graph is just that. So you just traverse the list of those nodes one by one. And the internal structure is like, so there's a loop, and for each OP, you call the OP invoke. Then the OP invoke will do it. And then, so let's start evolved. So previously, so when you want to use the underlying accelerator, you call an API delegate. So for an API delegate, previously it's all or nothing. If you cannot delegate all the graph into an API, then it fails. Now it's per OP based, and it's all the nodes become one node. It's something like this now. And as I said, I created an example label image, and besides the basic stuff, it has to read an image. So it's ridiculous that for image processing stuff, in Android and image processing stuff, image related API are provided as a Java API, so you cannot get it from the C++, so I have to write a bit decoder. Okay. Then let's do this. Okay. TensorFlow Lite uses a combination stuff called back compilation. Actually, it's not TensorFlow Lite. Its training is done. The back compilation is done on the TensorFlow before converted to TensorFlow Lite. And so before the real computation is done in eigen or GM and OP, but there are new stuff. Okay, this TensorFlow Lite. Before that, they only have an API stuff, and nowadays about 3 months ago, the GPU began. And why an NNAPI delegate? So let's check this. This is data from Google. It's about 1 month ago. And there are for NNAPI appeared in API label 27. Even if you believe this data, you only have 25% device that come with NNAPI data, NNAPI support, and not all of them are hardware accelerated. So Google created this one, and I also wrote some benchmark for the GPU delegate. Python, C, okay, C, the C API, C API is interesting. I even wrote a Smalltalk one. Smalltalk binding, yeah, Smalltalk is still alive. There are more new things. There are Objective-C, Swift API, microprocessor stuff, and ARM-based stuff is coming to come. There will be MLIR-based TFL converter. There is improved CPU backend. Let's skip the MLIR. Okay. There's a new ARM CPU kernel. It's turned on a couple weeks ago. Okay. This is kind of like a that. And there is a Capay 2, I skip this. And there are more open source frameworks. There are Xiaomi's Maze, Permissions, and CNN, and Microsoft Onyx stuff. And there is Ian, there are more and more. But none of them are as comprehensive as TensorFlow plus TensorFlow-like. And for start Iron Man open source, we have CoreML. We can see CoreML people's notes, and Qualcomm has its own stuff. I skip the Google HTPU stuff. One of the interesting feature of Google's HTPU is that it has something called imprinting. It's transfer-learning without retraining. It's transfer-learning, but the retraining does not use back propagation, does not use gradient descent. It's kind of like use a traditional KNN to replace the lattice layer and with some kind of mathematics. You can just replace this. Replace this, replace the next, so that's the layer, and with kind of KNN-based stuff. So you can train your edge device. It's kind of like this. Okay, I don't have time to talk about this. This is efficient and basically, I'm saying that it's not good. Okay, this is kind of the best slide. There are many trivial bugs in TensorFlow that I fixed this one line stuff. That's a logical error, and there are many typos in common in TensorFlow. Many things are not well documented. So if you are interested in TensorFlow, I think there are many opportunities. That's it. Okay, I think the time is up, but if you got any question, yeah, just ask. or you can come to me later. Okay. Thank you.
Okay. 现在再 show 一下你第一张那个 slide， 就是可以让大家扫描。If you didn't get the chance to find the slide, you still have 10 seconds.
Thank you very much. I have a question, but maybe I don't know what basically TensorFlow like. What is a little bit different from TensorFlow Lite between TensorFlow Lite and TensorFlow?
Yeah.
那爸爸是不是有拿出来？好。
So TM9 on devices.
Hello everyone, and this is a link of the slides, so if you want to download one, you can use this QR code.
If you want to download the slide in advance, it's your time. We are going to start in a minute. So. Good afternoon, everyone. Welcome to the HKOSCon special track. It's our honor to come to Hong Kong from Taiwan, and we are very glad to see you here. HKOSCon is an annual conference held by Taiwanese open source community since 2006. HKOSCon aims to provide the platform to connect open source coders, users, and promoters. This year on August, in Taipei, Taiwan, we will have more than 19 different topics from 14 tracks. You can join the BOF. You also have chance to share your ideas in lightning talks. And the registration starts in July 10th. So please come to our booth outside and you will find our poster that might have any information you might interested. And you also can follow our SNS like Facebook or Twitter. Just search HKOSCon and you will see the information. And now let's welcome to the Anqi, and he will share his opinions about the build a minimal DBMS from scratch by Rust. Let's give him a hand.
Okay, hello everyone. The topic is build a minimal DBMS from scratch by Rust. I'm Yuanqi. I used ID HKOSCon on the internet, including GitHub and Twitter. And I'm from Rust Taiwan community. There's a track in HKOSCon this year. It's everything in Rust. If you are interested in it, you can attend HKOSCon. And this is a slide. So what's Rust? Rust system programming language, and it runs best C and C++, but it focuses on memory safe, so you can ensure you have thread safety. People love Rust, and I'm also an advocate of Rust. According to the investigation by Stakeholder Fraud 2019, Rust is the most loved and wanted language. In fact, it also took the first place last year. What is DBMS? As you use MySQL is a DBMS. DBMS represents for database management system. If you want to store data, you probably save data into a database. And if you have many databases and many people want to access these databases, you probably need a system to help you to control the scheduler, to control memory, or control threads. So you need a system to help you. These are DBS. So why I do this? Why I want to build a minimal DBS from scratch by Rust? Think about these are textbooks. If you are majoring in computer science, you must do seen this before. How many people are there trying to build an operation system after they read the operation system concept, aka the dinosaur book? And how many people are there trying to build a processor after they read the computer organization and design? And how many people are there trying to build a compiler by themselves after they read the compilers? I thought there aren't too much maybe 20% or less. But I thought to learn knowledge, the best way is learn by doing. So I tried to implement every concept in the textbook to my project. Actually, it's inspired by this course. The professor is Ning Lo in National Taiwan University. It's database management system. So I built a project called Stellar SQL. It's written by Rust. I'm still working on it. So what a database management system is basically a server. A client will send a request to server. It might be looking for data or insert data to a database. And server will receive a query. You need to parse the query and you know what to do. So you find the data or write data to the disk file. And that's a simple architecture, but it is inefficient and it is very slow because you don't use multi-threads and you don't have a buffer. You know that file I/O is very expensive, so we need a better architecture to help us to do it best. So this is a big picture of our system. So we have a better protocol. We to deal with the query, their parser, planner, algebra, and we also have module about buffer and log. And to deal with the text file, we need metadata, index, record. And there are some issues about concurrency and recovery. So talk about the server and client parts first. I implement server parts to use Tokyo.s. It is a framework to deal with asynchronous multi-threads for connection because I want to focus on DBS implementation, so I don't want to put too much attention on the connection part. And the protocol I write based on TCP. And the protocol is very simple now. It just told the server the username, the database name, and what is the comment. And once the server receives the request, you will read the comment, and the comment is the query. And so we need to parse the query. And the query would like this from something, select something from something, and where something. We give the query to the parser, and the parser composed by two parts, lexer and parser. Because lexer would parse the text string to tokens, so we define some objects, symbol, group, and token. So we for this query, for example, we have select. Select is token select, and it is grouped in keywords. T1 is identifier and is also group identifier. And the symbol greater than is token GT and in the group operator. And we have tokens, so we can put it to the parser. I write a predictive recursive design parser because the query language is from left to right. So if it's a parser principle, so I use this. It is also easy to write by hand. I write the whole parser from scratch. The parser part also do the syntax track and semantic track. So the parser looks like this. We have tokens and we iterate token to one by one and parse it. And we parse the token to the abstract symbol tree. For example, the query list will translate to the right tree. And based on this tree, we can handle the logic easily, so we can find the data in the database. Then we know what we should do because we have already parsed the query, and we need to find the data in the disk. And this includes 3 parts: metadata, index, and records. The metadata records what database in this database management system, and what tables are in the database, and what pages in the table. And the data records in the page, so we write a page, includes header and many rows. A row is the data, and it is encoded to binary, so it would be more efficient. Once we have many pages, we want to looking for it faster, so we need index. And I implement B-class tree in the DBMS because the B-class tree is the most popular data structure in many DBMS, so I implement it. And B-class tree is just like normal. It's just like a binary tree, but each node has about 100 nodes, and there are 2 parts: the internal nodes and the leaf nodes. And internal nodes just records the key and the pointer to a node, and the leaf node include the right leaf and left leaf, and the pointer to the file. So the leaf are also the double linked list. So if you want to find a data such as from 5 to 10, you just traversal the tree to find the 5. You don't have to traversal the internal tree again because you can traversal the double linked list to find. So you just go through the underline. And what's to know is when we implement double linked list in Rust, is very different. For C++, we write code like this. We just need a pointer previous and pointer next. We create a node pointer and put it in. But in Rust, because Rust doesn't allow node pointers, so we have to write by option. Option are either some or none. Rust also doesn't allow you to modify pointer directory, so you have to write by the ref cell, so you can by this ref cell you can modify the object. And the arc operator, the arc wrapper ensure you can modify the data safe between threads. So we have the track like this. We won't access data every time from the storage, so we have to record it in the memory, so we have buffer. So we read page from the storage and we store it in the buffer pool and use page table to record this. Once the page table is full and we flush out and write back to the storage, we can put another new page in it. And there's a module log. Every querying we record queries in the disk. And once we write to disk successfully, we return OK to client. And at that time, the data haven't written to the storage, it could be in the memory, but it's okay because we have a log. If server crash or something error, we still can recover by this log. And there are two issues about concurrency and recovery. Because this is a big issue, so I just take some example to tell what I will do. Concurrency include index and transaction. Take these two operations, for example. We first insert 14 in this buffer tree. So we want to insert 14, so we look first we are in 20 and we lock. Then we find 10 and we give a latch for it. And because 20 is safe, so we release the latch. And then we find 14 should be here because it's empty, so we should put it in. But we need to create a new leaf page for it. So there are 4 pages here need to give latch for it. And when we want to search 22, by the way, we are doing this at the same time because it's concurrency condition. So we are first we looking for 20 and give a latch for it, and we looking for 35 and release the 20, and we go to 23. And at this moment, because writing to file costs more time, so it might still have a latch, so we need to wait for it. And once it releases its latch, and we can, the search operation can use that page. That's an example, and the other example is we might have many transactions, and a transaction includes many operations, just like the right one. A transaction begins from start and ends by the commit, and we have so many transactions here. But in a single thread, it is too slow, so we might want to have many threads to deal with it. So I use 2 transactions, for example. So we can take these 2 transactions to 2 threads. So we have the schedules like this. So because it has 2 threads, so we save some time and it will go faster. Recovery part is also very important because we don't know what time the server crash or what if the transaction error or something unexpected happen. So we need this recovery module, and it's based on the log module. And I haven't implemented it yet, but I will implement it later. So that's the architecture of my project, and the project is statistical and it's QR code. And I want to have a demo for you. So I run the DBMS, and I write a client by Python. So we turn on the client. So first, the user needs login, so we log in first. Because the database are empty, so we need to create a database for it. So we create a database. And then we need to create a table for it. So we have table, and it had A1, B1, and C1. Then we insert data into it. So we insert some data. So there are 3 sets of data in this table. And then we would want to search something. So we set a predicate for it, which is A1 bigger than 1. So when we set a query, so as you can see, there are only 2 sets data because the data that A1 smaller than equal 1 is not here. So this one is not here. And then we can set more condition, which is C1 greater than 2. So another data is not here. So C1 needs to greater than 2. So C1 greater than 2. So this one is not here. So only here are in the result. So the next one is also a query. So the next query leads to the result that all data are here. So we can see the 3 sets of data are in the result. So that's the demo for you. There's another great course. It's opened by CMU. It's called Database System, and the professor is Andy Powell. And I thought it's a great course. If you are interested in this topic, you can take a look. And thank you. So, do you have any questions?
Are you using a rule-based optimizer or cost-based?
Cost-based.
So when it needs to do the query, whether it decides which index, if you've got multiple indexes, how does it determine which index to use or whether to do a full table scan?
I don't understand.
So if you have a table with say 100 rows and you have 2 indexes on 2 different columns, how will you decide which index to use? Is it based on the cost of the estimate of the number of rows, or is it rule-based? So if there is an index, it will always try to use the index?
Yeah, you always try to use the index. We only have one instant. So, do you have any question? Okay.
Is there any question? If not, that we will have a whole track of Rust in HKOSCon. So if you are interested in Rust and if you are going to HKOSCon, you can find us and listen to more Rust talk. See you. everyone. Nice to see you here. We are the HKOSCon special track, and we are very happy to be here, and we are more happy to see you here. The HKOSCon is an annual conference held by Taiwanese open source communities since 2006, and we are aim to provide a platform for open source coders, users, and promoters. And this year, on August 17 to 18, in Taipei, Taiwan, we will have more than 19 different topics from 14 tracks. You can join the BOF. You also have chance to share your ideas in lightning talks. And the registration starts in July 10th. So please come to our booth outside, and you can see the poster that may have the information that you are interested. Or you can follow us on Facebook or Twitter. Just search HKOSCon and you will get everything you need. So hope to see you guys in Taiwan. And now we are going to welcome the Date Huang, and he will sharing with the decentralized bare metal operating system provisioning. Okay, let's give him a hand.
Hi everyone, I'm Date Huang, in Chinese Huang Yuqiang. I found a dozen cloud on V8 Cloud for BPS, and I'm now is HKOSCon Network Senior Engineer. Our company is doing the SDN solution for data center, cloud, HPC. Nowadays, the cloud takes change fast, very fast. Infrastructure as a code for system provisioning and service deployment will be more requirement, more data center will need it because we need to redeploy the operating system to the bare metal servers. So we will focus on the bare metal system provisioning toolkit to show you how the nowadays works and our solutions. Yes. In legacy approach is for now. For the message system provisioning, we will use the unicast and the multicast to transfer the operating system image to the server disk. Or maybe we will save the temporary image into a RAM or another partition or the disk and ready to restore to with our target server disk. Yes, if you can see in the toolkit, we'll see unicast. We can file the metal as a service, which made by Canonical, and OpenStack Ironic, made by OpenStack Foundation. And the multicast part, we have Clonezilla Server Edition, that is made in Taiwan, and the Symantec Ghost Solution Suite, that can do the same job. Okay, this will be a part of the network stacks difference. If you use the unicast to deploy your servers, you can see we will need to link to the receiver. If all the 4 computers need to receive the data, it will share the server's bandwidth. If you use the broadcast, you can just send one packet and switch will copy to all of the others PC. And multicast multicast can choose the receiver. We don't need to transfer the data to all of the PC in the networks. We can choose maybe we just want A and B or A, B, D. We don't need to transfer the data to the C. Yes. What is problem need to be solved? We need to cost lots of time, and the renaming time is not predictable because every issue will cause the system provision process stop. If you use the unicast, targets will share the server's bandwidth unicast. So it will be a difficult issue to you if you want to scale out, scale up, even your data center want to grow. So it will be an issue. And because share the server's bandwidth, so the process will be slowed down if your scale is bigger than before. Yes. And targets are not always stable. Need to transfer the data blocks via the multicast because if you want to transfer the data using a multicast, you only can use the UDP, so you can't handshake to all the receivers. So if the a client doesn't receive the data, so they have to notify the server, I lost the data, you have to transfer to me. So for the others, there will be an issue is, I will receive the same packet I received the last time. So it will be a slowdown issue to the multicast deployment. And that's the important problem is multicast used to join the receive group at the same time. You can't just they just transfer data and I want to join at this time. We can't. We need to wait till our multicast process is end, and we can restart a new multicast session to transfer the data. Okay, so unicast is very hard to scale up and out. So there will be the server's bandwidth isn't enough if you have a large scale, you have large PC, you have maybe your image is so large, there will be a problem. And multicast and broadcast is not always available because enterprise network and the public cloud maybe disallow multicast and broadcast to you because there will be a security issue or something, so they don't allow you to use a multicast. And in nowadays clouds, they will do the L2 less data center, so it can't use multicast because there's no L2. So you just need to transfer over the data by the routing, by the others, by maybe some EVPN or some L2 VPN or something. So multicasts are not always available. So in this case, in L2 data center, they need to go back to use the unicast to deploy. So they will face the problem is the first one. So scale out problem, yes. So we chose the BitTorrent. Why about the BitTorrent? You are inspired by some open source project in the past of the 30 years or something. They want to share their software, but their bandwidth is not so enough because the money is the bandwidth is so expensive. So they use the peer-to-peer to share their software because I can share to one user and they can share to others. So I can borrow user A's bandwidth to share to the user B. So I can use a small bandwidth and that is more efficiency. So we just want to develop a BitTorrent-based system permissionally. We want to avoid multicast and broadcast. We want to synchronize data transfer because we don't want to each system permission need to start at the same time because maybe we just want to start from 1 and 2 and others will pick up later or something. So if they will start later, so I will need to avoid and use a synchronized data transfer. And it will reduce the image provider networking loading. So you can use you can use a little bandwidth to provide the huge data centers. Yes. So you can see is the graphic. So if you want to, you can see just sorry. Yeah, if this is a seeder, so you can see we can share to others, and if you want, it's from this peer want to get the data, he can get from here, here, or here, here, anywhere. They can get the data from anywhere. So we can set the server's bandwidth now and to use others for others purpose or something. So challenge in a BitTorrent. For peer-to-peer file sharing, temporary storage is required. So we can often getting data sources in BitTorrent. So I can assume I will get the page 1 after the page 0. Maybe it will change reverse order or something. So I can't assume anything. And so we need to store the whole disk image into the temporary storage. So for bare metal provisioning, the average storage is only a RAM because the data, the disk is your target. So you can write your target. So even you slide the disk to 2 partitions, that will limit your usage for the disk image. So you can maybe your disk image just have to be half of the disk. You can be a whole disk image to transfer to the host. So image size will be limited by the RAM size or your partition size for the temporary storage. So we developed a brand new method, AZL, compared with the regular BitTorrent protocol using the BitTorrent reservoir. So we can seek and process the image with the regular BitTorrent clients like QBitTorrent or transmissions. And the important part, we write image from into the disk directly. Yes, so we don't need any temporary storage to store image for converting or restoring to the disk or read from the disk. We don't need to that. So let's see the design. We redesigned the bit compatible image format. You can see if this is a file system, we can know this is used, but we don't care. It's used, so we need to transfer this part and this part. It start at 0 and it start at A0000. Okay. Okay. So we dump this file system into the files. You can see this is 0000 in hex, and this is length of this part. So you can, this is one file and this is the second file. Okay. Okay. Because it's like the design, so we can record all the continuous block into the torrent. So you can see it will be 4 files. It means this file system has 4 continuous blocks, and others don't care. We don't need to transfer that. So we can calculate short hash to verify. So you can see do a piece and compare with some short files. It will be when you download or you upload, you will calculate and verify it and make sure it is correct. So make sure the file system will be the same. Okay, that is the transfer part. Piece is the minimum unit in the BitTorrent. So if you want to transfer data, you will transfer a piece in a time. So when you transfer a piece to the others, and they will use this short hash to verify if this piece is correct. Yeah, it is correct. And we will try to figure out where this piece, where this considers where the file system offset is. And for example, if we receive in piece 1, we will figure out also that is from 100 to 108200. So we can use this information, write the piece, the front part and the back part into the file system, into a disk correctly offset, and we can do the directly rewrite from the disk. So we use a new format to make sure we can we don't need temporary storage in BitTorrent because we try to design a BT format. Yes. As I compare with the legacy approach, we use this case, message office or operations deployment to multiple servers in data center. We are not data center, we use HPC. OS image is larger than 50 gigabyte. It's important because too small, BT isn't really good in a small scale size. We can discuss later. So our environment is 1 gigabit per second and 50 gigabytes data in the disk. Yeah, and we have let me show. 1 terabyte hard disk. So we just need to transfer 50 gigabyte data in the disk. So in legacy approach like Clonezilla multicast mode, so it's slow because we only have half gigabytes per minute. So it's about 8 megabytes per second to 34 megabytes per second. It will really slow in 1 gigabit network environment because we have multicast have to wait all the data, all the client receive this data and then he will transfer the next. So he will need to wait too much time when if servers is temporarily stop or something. So and if one server stop, and all the servers will stop on this process. Yes. So and they cannot use be in a L2 last environment. Broadcast and multicast are not available. Yes. So when using the BitTorrent deployment, we can get about 2.5 to 4.5 gigabytes per minute, and you will close to disk random access speed. This will be disk random access speed. So we can get more performance and reliable and flexibly improve from heterogeneous environment, because if you combine the lots of PC with maybe they are not set the same settings or something. Maybe some is 100 megabits network, some is 100 gigabits network. If you use a multicast to transfer data, they will the speed will limited by the slowed part in the system. The most slow part in the system. And if you will use the BitTorrent, they don't care. They don't care about this. If you want to fast, I will get you fast. You can go fast, okay, then we just use 100 megabits to transfer. So they were independent, not just independent. So we can, if once server stops, others can continue and no impact at all. If one server is down, they just keep going, and as down server we can fix it and then join it back to the restore group or deployment group. So and it can use be in a L2S environment because it's just a unicast program. So you can transfer the data with a handshake or something, with routing something. You don't need to any multicast, broadcast, yes. So that's what our result in this test. You can see that is the time per second, this times in second, the time in second. So it will be interesting is this. This increase, yes, of course. This increase, yes, of course. But it is almost constant times. You can see. When you are have 2 classes and you have 32 classes, you can see the time almost constant. We have tried in our journal paper. We have tried for 1 to 33, 1 by 1, at 1 and 1. Yes, we can Metafly is almost constant time, and it just depends on what we setting on AZL. Even we can tune it to almost, we want to transfer to 32 PCs, we can use the same time as the one PC. We can tune. We try to tune the performance to this part, but it was too difficult to do. So we try to tune the performance to the clients of truth, because it is fast enough to us, because you can see we almost save the half of time compared with the multicast. We save almost half. So we're still working on. We want to use gRPC to control the AZIO daemons, because my project is using a GPL v2 to open source. I want to protect that this knowledge of directing to write and read directing disks, but I want to promote it to. I think it will be a cool project for a parameter solution or something. So I want to use the gRPC support to spread the server and the client. You can do anything you want in the client. I don't want to carry that one. Yes. So if you, I will try to export all the libtorrent reciprocal API to gRPC support, and you can use your client to connect it and tune it or something. You want to make some performance tuning or something, remote control to make your process more fit your what you requirement. Yeah. So we are trying to test with OpenStack, Ironic, and Metal as a service, because about the OpenStack, Ironic, Miratics, the company, they do the torrent deployment in the 2060 last, or I really don't remember what the time correctly. They want to try to speed up the OpenStack Ironic to deploy the operating system, but they don't know how. They just use the DD to DD all the disk to image, and use the raw image and use the BT to transfer to the server's RAM, and use the RAM as a temporary storage, and copy the RAM data to the disk. So they are fast the problem we discussed on the previous. We now don't need to do any temporary storage to store any image or hold the image. We don't need to do that. So we are trying to test with OpenStack Ironic and Metal as a service. Okay, so any questions? There will be my personal email and there will be my company email. Yes?
Is there any HPC cluster has already used EZIO already?
I would say not yet, but it will be very soon to use, because I say the hold on. Okay, this Clonezilla Server Edition made in Taiwan, yes. Then why they develop the Clonezilla? Because there are national organization for the HPC. They want to speed up their HPC installing, so they develop the Clonezilla Server Edition, and our AZIO is integrating into the Clonezilla. So you want to use EZIO, the most easier way is download the Clonezilla for the last version, and you can use the EZIO to deploy what you want. If you want more flexibility, you can just use our project and use some Clonezilla's open source project and to make your own solutions. Still have questions? Okay, thank you. This is my journal paper. And I and Columbia's development team to publish it together. So you can, if you want to detail, you can study the paper or just trace the code. It's not so long to about less than 500 codes because I use the libtorrent recipe as possible as I can. So we don't need write the code on our own too much. Yeah. So if you want to research in this stuff, you can use these 3 links. You can know of everything. Thank you.
everyone. Welcome to HKOSCon special track. And it's our last talk today. And we are really happy to see you guys here. And HKOSCon is an annual conference held by Taiwanese open source community since 2006. And HKOSCon aims to provide a platform to connect open source coders, users, and promoters. And this year, on August 17 to 18 in Taipei, Taiwan, we will have more than 19 different topics from 14 tracks. You can join the BOF, you can meet new friends, and you can also share your ideas in lightning talks. The registration starts in July 10th. So please come to our booth outside. You can see the more information, and you can also follow our SNS like Facebook or Twitter. Just search HKOSCon, and you can get any information you might need. Hope to see you guys in Taiwan. And today our last speaker, Tai, joins Canonical in 2013 to contribute to Flows More and is active to organize PyCon TW. He loves to combine flows and science, and now he's going to share the homemade scientific clusters. Let's give him a hand.
Thank you. Thanks for the introduction. And that's fine. It's already last one, so I think it's tired as well. And thanks for being here because it's a long day, isn't it? Finally, it's the last one. And before I started, that's fine. Take your time, please. Before I started, I would like to know how many of you have attended the last talk. May you raise your hand to just let me know. Because the last talk is a little bit related to this one. So how many of you attended the last one? Okay, thank you. And okay. And how many of you are users or know the operation system Ubuntu, the desktop Ubuntu? So how many of you? Oh, that's great. Okay. And thank you. Before I start, you can refer to this link. I summarize all the technical details in this document. It's a HackMD document, so you can not only read the document, you can also edit the document and share your idea with the others on the notes. So please relax. You don't need to worry about missing any details. I have summarized the details of it, so just focus on already the last one, so let's just relax a bit and check over carefully. And thanks for raising your hand. I am a software engineer working for Canonical, which is the commercial company behind Ubuntu. And today I'm not going to talk about Ubuntu that much. I asked the question of how to Ubuntu. And my name is Tai, E-A-I, which is the same as Taiwan, Tai. Yeah, exactly the same alphabets. And some of you might wonder this is my email address. You can email me over the address. Some of you might feel weird what's these weird numbers means. It's actually a part of the irrational number constant, exponential constant. It's a part of the constant 2.71828. And the reason that one of the reasons that I picked up an irrational number as part of my nickname on the internet because I don't want to think of a new nickname or ID when there is a duplicate account when I register a new account on the website. Because it's an irrational number, it has infinite digits, so you can just add in one more digit and you will have a brand new account and everyone, you can still identify yourself. And the other reason that I picked up the exponential constants as part of my nickname, because this exponential constant is actually a part of the universe. It's a part of the nature. And before joining Canonical, I was a physicist, literally. I joined the Diabei collaboration, Diabei, which is the Diabei nearby Hong Kong. It's just the Diabei 50 kilometers away from Hong Kong, I guess. And the goal of Diabei collaboration is to find out the smallest particle in the universe. We try to know the mass of the particle. The name of the particle is neutrino. And the collaboration is composed of 40% of scientists from American, and 40% for China, and 10% from the other countries, including Taiwan, Hong Kong, and so on and so on. And our collaboration was awarded Breakthrough Prize in 2015. The prize was funded by a big company like Facebook and Alibaba to encourage the fundamental research, because fundamental research does not make a lot of money, so they try to encourage people to keep working on this kind of stuff. So even, so I tweaked a bit my career plan, because I would like to involve more open source, free software stuff, so I joined Canonical. But before joining Canonical, I still, after joining Canonical, I still remember that I love to study the universe, about like physics and scientific problems, something like that. But when I was a member of the collaboration, I have the permission to use a very powerful supercomputer of Lawrence Berkeley National Lab. It's a very, very powerful computer, so we can simulate the data that we collect nearby Diabei nuclear power plant. We can reconstruct the even signal with a lot of data to find out the particle signal we want to see. But what if when I left the academic collaboration, the first issues happened to me is I don't have any permission to use a very powerful supercomputer, but I still try to study some physics problems and questions all of my work. So the first thing came to my mind is the thriving computing resource nowadays, thanks for the cloud technology. There are plenty of cloud resource on the computing resource on the public cloud. So you have plenty computing resource, literally, unless you can pay the bill. So if you have trained your AI models, if you are rich, you can just buy a lot of, or borrow a lot of computing resource and train your model within 2 days probably, and pay thousands US dollars, for example. But as an individual, I don't want to pay that bill that much. So is there any local prototype for me? What if, for example, what if the nodes are composed of a container, a virtual machines, or even more? It probably could be a old or abandoned personal desktop, like we call it bare metal. So I think the previous talk about bare metal provision stuff. So thanks for working with details. I don't need to elaborate it again. So I think I have a lot of useless desktop when in the past 10 years. I believe many of you has your abandoned useless desktop. So Canonical has a product called MAS. MAS means Metal as Service. It means you can use MAS to easily control and convert your own desktop, or more generally, your bare metals into a private cloud, your own cloud, easily. How easy is it? If you are one of the users, you can just type these commands, just only one line commands sudo apt-get install MAS, and that's it. That's it. That's the whole story. You don't need to. Oh, thank you. Excuse me, if the last audience can hear me. Okay, clear. Thank you. All right. Is that better? Okay. Yeah, it's a stand-alone application. So run my commands, and you will get this is a dashboard of MAS, and that's it. It's ready to connect your bare metal over PC. The only request that it requires is your bare metal should support PC, which is already being supported by default in modern machines. So the very usual typical working type is, firstly, we if I have idea to develop an application, we probably use a container to try our application. And once the application is ready, we probably want to know the benchmark or performance of bare metal machines, and then move to, and everything is okay, the performance is good, and the application logic is good. So let's move the whole story to the charge is public or private cloud. And so I don't need to waste my money and my time to use public cloud when I cook my prototype. Very typical. I think everyone think of this kind of working flow. So this is a very short summary that I compare different solutions from containers or virtual machines with KDE, for example, and bare metal with use public cloud as a solution. For container, regarding container, we probably use LXD, which is also Canonical's product based on LXC technology of kernel. And for KDE virtual machines, you can control the virtual machine over MAS as well, like what you have done for bare metal stuff. And everything is ready. Okay, let's move to public cloud like GCE or Amazon stuff if you like. So there are so many different kind of clouds. Is there any possible to have one solution for all types of cloud? Could I just write one code and deploy your service or application to all different types of cloud, like local containers, bare metals, or public cloud? And the Juju ecosystem is one solution that you might consider to use. For example, this is you, and this is your cloud or cluster, no matter it is LXD, MAS, or a public cloud. You can just, okay, this is my color issue. Probably you can see here is better. Juju. Juju means magic, and magic is African, some kind of African language I barely remember, but use Juju magic to spell your chunks and control the cloud, no matter what type of cloud it is. And what you need to do is write a chunk, and that's it. Okay, the core idea here is write one chunk, all keys chunk on every cloud. I will take an example here, which is my side project. I have implemented all of my work. And you can go to Juju store, which everyone can upload your own chunk to the store, and everyone can share it like a Play Store. And you can just search SGE. It means some grid engine. Some grid engine is a usual scheduler used in an HPC cluster. And I will show you how I set up a SunGrid engine-based HPC cluster later with the Juju Chunk ecosystem technology. And if you search on Juju Web Store, you can see something like this. It illustrates the relation between a SunGrid engine master service between the SunGrid engine client service. The relationship is a very simple one, just a master and client model. Okay, how do we write a chunk? To write a chunk, the code, firstly you have to prepare your own chunk layers. This is what you need to do, the only thing you need to do. And compile your chunk layers with chunk tools. It's just, a chunk tool is just like a compiler, but it just compiled your layers. So chunk tool compile chunk layers, and you will get a real chunk. And then this real chunk could be deployed, could control, managed by Juju. Okay, this is the example. Okay, this is better. Okay. Thank you. Thanks for myself to bring a laser. Okay. Okay, the core idea is to write a chunk is when you write a chunk. In this example, I write a chunk in Python, and you can write a chunk with any language you want. The officially support language is Python and Bash shell script, but actually you can write in the other language like the other. That's just like the other language. Only if it has a community support layers, chunk layers, and that's enough. And another core idea to write a chunk is to write a chunk. The pattern here, the design pattern here is a React pattern. You can just Google React pattern on Wikipedia, and it's a kind of design pattern. In short, a design pattern is a status trigger event. For example, when Grid Engine Master is installed, when mpage package is installed, blah blah blah. For example, when kernel MFS server is installed, is ready, then execute this function. So you can use this kind of pattern to control the node you want to deploy. And very similar to the previous one is to deploy a master node, and very similar to master node, you can do the similar stuff to write a chunk for a client node. Okay, that's back to here. Okay, let me illustrate how it works overall. Firstly, you deploy a master node, and then you tell Juju to build a relation between, try to build a relation between master and client. When you create a master, the master is not aware of the client until the master communicates with client over this relation. And the connect point, we call it an endpoint. The connect point between the node and the relation is an endpoint. And okay, that's big to here. Okay, when the endpoint join the node here, then do stuff, publish host private address. So the master will publish its private address over the relation. The master itself has no idea where the address will be propagated, but it just propagates over the relation. Okay, in this case, similar to master, the client was published its own information over relation. And we know from these pictures, we know both of the information was master passed its own information to client over relationship and so on and so on. So both of the nodes from now on could aware of each other. Okay, and then similar to the previous one, you can create more client nodes and add the relationship, so you can have your own cluster. So chunk, a short summary. Chunk are written in Python, and you can write in the other language, but the core idea is this React pattern. Add compile from chunk layers with chunk tool. Okay, demo. Finally. Okay. Serious, I probably need to demo more than 15 minutes. I try to speed up. Okay. Okay. Oh, hold on. All right. Before I demo, I would like to, that might be better. Okay. What I want to demo here is, okay, this is the whole solution, a real world cluster that I built on top of the solution I just illustrated. I built the infrastructure with the Juju MS technology, and I used Singularity. Singularity is a container technology developed by Lawrence Berkeley Lab as well. Was used widely by HPC institute like Stanford, Lawrence Berkeley, many famous national labs. It's a container technology specific for scientific purpose. And in these containers, I will try to run a real world a computing fluid dynamic application. It's a framework, Softcom, to try to simulate a real world, try to simulate the classic computing fluid dynamic programs. We call it SOP2. SOP is a scientist name. This is a famous classic benchmark physics questions. Oops. And I wish I have enough time. It's demo, but honestly, it's just semi-demo because deploy takes a lot of time, so I try to record the result. Okay. The deploy time actually takes more than 30 minutes. I don't believe anyone wants to wait that long. So, okay, firstly, let's Juju status show there's nothing inside my Juju ecosystem, and I add a model in the Juju. So for now, Juju status show, okay, now we have a new model, but the model is empty and ready for you to deploy your node. And firstly, please remember that we want to compile our chunk layers into a real chunk. And okay, probably smaller. Okay, this. Okay, maybe a little bit smaller.
Smaller.
Okay, less.
I guess.
Did you like a bigger or smaller? Both, or is a fair enough? Okay.
I guess you may need to take a look on the side.
Okay, thank you very much. Okay, yes. Okay, I just prepared the build environment here, and I go to the layer, this is the layer source code, and I try to show you here, there's nothing not built chunk here, and I go to the source, layer source here. You can download over GitHub, and the link is in the HackMD document. Let me speed up a bit. Let's build it. Chunk build. Okay, and then build take a bit. Yes, okay. And then you can see, okay, the build folder here, so you can see I already have. Hold on. Okay, I already have the chunk, a real chunk ready to be deployed by Juju. Okay, almost run out of time. Okay, similar to master, let's build a client. Okay, similar one. Okay, and everything's ready. So let's. There's nothing here for now, and let's. Okay, this is the key command here. Juju deploy. So we try to deploy the master node here, and I would like to constrain the node is built on top of Xenial. Ubuntu Xenial is one of the distribution of Ubuntu, and I would like to constrain it was deployed on a virtual node. Okay. Okay, that's okay. You can see the machine's pending, and that's maybe smaller. Maybe too small. Okay, that's for some reason I need to resize it unless the terminal text will destroy. Okay, but let's speed up because it takes a bit more time here. Let's speed up. Okay. And similar to master, you can deploy the client here. Maybe too small. That's right. Okay, I will skip the okay. Oops. Okay. So it's kind of embarrassed, but it might be too small, but thank you for your understanding. Okay, in the status dashboard, you can see I have deployed the master, and I try to create 2 more nodes here. So there will be 3 clients and 1 master here, and I just waiting for the machine is ready. Okay, let me speed up because to install the system it takes really a lot of time. Let me speed up.
Question?
Please.
Is the machine LXD container or a bare metal machine?
A bare metal.
Okay.
But all of the client nodes are bare metal, but the master node is deployed to a KVM. I try to mix up all of them to show the power of mass. Mass will control both KVM and bare metal.
Awesome.
Let me speed up a bit. Really takes time. Okay, it's install some great engine here for now. Maybe. Oh, I hear the sound to push me. Oops. Okay. Okay. Let me just. Okay. Well, here. Why is it still so small? Okay, you can see here. This is some great engine stuff. Here, this part. There are 3 client nodes just deployed over Juju here. And this, the Q host is the command of the software engine. It's okay. And the cluster is ready, so let's do run real MPI program here. It's a MPI hello world. And submit some jobs, hello world jobs here. Let me just enlarge the text. Okay, make it better. So you can see, I just submit the jobs, and you can see the process return from different nodes over MPI program. It's just, you can get the hello world string from distributed nodes. Okay, now it's time to rock. Let's pull the singularity images here. Move faster, faster, faster. Okay, I got the image. And I try to issue some softcom commands here. And this is softcom application. Oh, okay, you can see it begins to simulate the computing flow with dynamic questions. All of the projects used here, from Juju to mass, from Juju to mass, from Singularity to softcom, all of them are open source projects. So, okay, you can get the simulate result. So, The results is shown here, and you got the classic SHA-2 questions here. It was computed by the cluster I just showed to you. And all of them are take-home messages. All of them are open source projects. So move on and create more pull requests against the project that you are interested in, and waiting for your comment. Thank you very much. If you didn't get it, you can. Do I have any time for the question? No? Okay.
Is there any question? Feel free to ask. If not, thank you for your time to join us and join the HKOSCon special track. And we really want to have you in HKOSCon in Taiwan. So please, you can stay tuned our SNS like Facebook or Twitter. Just search HKOSCon and see you then. Thank you.